Dear students, in this class we are going to discuss about the concept of balancing of chemical equations. For explaining this concept, I am taking one of the example, that is combustion of propane. Combustion, what it means? Combustion means the burning of the substances in the presence of air, particularly in the presence of oxygen. Now I am taking that substance C3H8. It is a propane. It is a colorless gas and it is a odorless gas and it is a organic substance and it is a hydrocarbon. Generally it burns in the presence of oxygen. It gives a large amount of heat energy. That's why it is using as a fuel. Now for the combustion reactions, generally the requirable gas is the oxygen. Now I am providing some amounts of oxygen to this substance for the burning. Supplying some oxygen to the propane for the burning. Propane that burns in the presence of oxygen and forms two new substances. They are carbon dioxide and H2O along with heat energies. Now look at this one. Here the first substances are propane and oxygen. It is burned in the presence of this one and gives rise to these new substances. So first substances, previous substances are two, propane and oxygen. New substances, carbon dioxide and H2O. That's why straightly we can say it is a chemical change. So chemical change is occurring here. That's why straightly we can say it is a chemical reaction. It is a chemical reaction. Now we have to balance this chemical reaction. Generally 4 steps are using for the balancing of chemical equations. The first step is what it says. It says write the unbalanced equation using correct chemical formulae for all the substances. For all the substances means reactants and products. Reactants, that means which are involved, which are participated in a reaction. Products means which are formed in a chemical reaction. Now according to this step 1, I am writing the unbalanced equation based on those ones. Firstly I am writing these ones in the left side because those are the reactants. C3H8 plus O2. These two are reacted with each other and given these two products. I am writing those products in the right side. CO2 plus H2O. Look at this one. It is an unbalanced equation and it containing only chemical formulas. This kind of equation is generally known as skeleton equation. It is an unbalanced equation and it containing only chemical formulas of all the substances. That's why it is called as skeleton equation. Now we will go to second step. Step 2. It says compare number of atoms of each element on both sides. So that means we have to compare the total number of atoms of each element which are present on both sides of a skeleton equation. Firstly, we have to write a skeleton equation. The skeleton equation is C3H8 plus O2 gives less to CO2 plus H2O. By the observation of this equation, I am drawn one of the table. This table tells about the total number of atoms of each and every element which are present on both sides. On both sides means left hand side as well as in the right hand side. Observe this chemical equation. In this chemical equation, which type of elements are there? Carbon is there, hydrogens also there, oxygens also there. That means 3 types of elements are there. Those 3 types of elements are, I am writing here, carbon, hydrogen and oxygen. Now, by the observation of this equation, how many number of carbon atoms are there in the left side? Similarly, how many are there in the right side? I am writing in this table. Carbon atoms, 3 are present. Observe here, 3 atoms are there, 3 carbon atoms are there in the left side. Those carbon atoms are present in which molecule? In C3H8 molecule. So, that information I am written in this table. 3, they are present in C3H8. Similarly, in the right side, only one carbon atom is there, that is present in the CO2. I am written that one here, 1 carbon atom, that is in CO2. In the same way, hydrogen atoms, 8 are there in the left side, they are present in the C3H8 substance, 8 in C3H8. In the right side, observe here, 2 hydrogen atoms are there. These 2 hydrogen atoms are present in H2O molecule. Finally, oxygen atoms. So, oxygen atoms in the left side, 2 are present. They are in the form of O2. So, I am writing that information in this table. Oxygen atoms, 2, they are present in O2. And in the right side, here 2 oxygen atoms in CO2, 1 oxygen atom in H2O. Total number of oxygen atoms are 3. I am writing that one in this table, 3 in CO2 and H2O. In this way, I am comparing all the atoms of elements which are present on both sides. That means in the reactants side and in the products side. And now, I am writing this skeleton equation, C3H8 plus O2 gives less to CO2 plus H2O. Coefficients. Coefficients means those are the numbers which are present before the chemical formulas of all the substances. So that means maybe reactants or the products. Here C3H8. Before this one there is no number. There is no number means generally we are assuming 1 is there before the C3H8. Now the coefficient of this molecule is 1. Similarly here no number, that's why I am assuming only 1 that is present before the O2. The coefficient of O2 is also 1. Similarly here also 1 is the coefficient, here also 1 is the coefficient. So according to step 2, find the coefficients to balance the equation. That means we have to find a new coefficient which has to put before the chemical formulas for the balancing of chemical equation. Now, observing this table, now I am balancing the chemical equation. Among all the substances, this is the complex molecule because it containing more number of atoms. Generally, the chemical species which is containing more number of atoms, that is generally we are saying complex molecule, that has to select to balance the chemical equation. Now I am selecting this one. So in this molecule, the carbon atoms in the left side 3 are there, in the right side only 1 is there. To balance the carbon atoms, now I am changing the coefficient before the CO2. So writing here C3H8 plus O2 gives less 2. Now I am putting 3 before the CO2 because 3 into 1, 3. Here 3 carbon atoms. Now all the carbon atoms are balanced. So observe here I am saying another word. We have to change only the coefficients before the chemical formulas, but not change the chemical formulas which are present in a chemical equation, right? And the next one, carbon atoms are balanced. Next one, hydrogen atoms. Here in the left side, 8 hydrogen atoms are there. In the right side, only 2 hydrogen atoms are there. So that's why in the right side, less number of hydrogens are there. So that's why for balancing of hydrogen atoms, we have to change the coefficient before this molecule. I am changing the coefficient which is belongs to H2. Now I am writing C3H8 plus O2 gives us to 3CO2 plus 4. I am putting 4 H2O. 4 to the 8. Here 8 hydrogen atoms. All the hydrogen atoms are balanced. Finally, we have to balance the oxygen atoms in this equation. Observe here in this equation, in the left side 2 oxygen atoms are there. In the right side 3 2s are 6 plus 4 1s are 4. 6 plus 4 equal to 10. Total number of oxygen atoms in the right side 10. That means as compared to the oxygen atoms in the left side, more number of oxygens are there in the right side. That's why we have to balance these oxygen atoms by finding a suitable coefficient. And now I am changing the coefficient of O2 molecule because here less number of oxygen atoms are there. That's why I am changing the coefficient of this molecule. Observe here C3H8 plus 5O2 gives less to 3CO2 plus 4H2O. Now 5 is placed before the O2. So 5 used as a coefficient that is placed before the O2. Now 5 2s are 10 and here 10 oxygen atoms in the right side. So now the oxygen atoms are balanced. In this way, the chemical equation is balancing by using the step 2. Step 3. According to this step, the coefficients of all the substances in a chemical equation must be smallest whole number values. It means in a balanced chemical equation, each and every coefficient of a chemical substance must be a smallest whole number value. For example, I am writing the previous equation which is balanced by us, that is C3H8 plus 5O2 gives less to 3CO2 plus 4H2O. Here these are the reactants and these are the products. And reactant side I am saying C3H8 has a coefficient 1, O2 has a coefficient 5, CO2 coefficient is 3 and H2O coefficient is 4. Each and every coefficient, observe here, each and every coefficient is the smallest whole number. In this equation, there is no need to reduce these coefficients to smallest whole number values. But this kind of situation might not be achieved in each and every chemical reaction. For example, I am writing one of the chemical reaction which is balanced. Observe here 2 C3H8 plus 10 O2 gives less to 6 CO2 plus 8 H2O. As per rules, it is a balanced chemical equation. It is a balanced equation. But in this equation, all the coefficients are not smallest whole number values. It would be necessary to divide all the coefficients in this equation by 2 to reach the final equation. For example, now I am dividing each and every coefficient with the 2 for getting the final equation. Observe here 2 divided by 2 will become only 1 C3H8 plus 10 by 2, 5 O2 gives less to 6 by 2, 3 CO2 plus 8 by 2, 4 H2O. This equation, in this equation each and every coefficient has a smallest whole number. Last step, step 4. In this step we have to check the answer and count the number and kinds of atoms on both sides of the equation to make sure they are the same. For example, I am writing the final equation which is balanced by as C3H8 plus 5O2 gives less to 3CO2 plus 4H2O. According to this step, we have to check the answer. That means how many number of atoms are there in the left side and how many number of atoms are there in the right side, whether they are balanced or not. Now I am checking that one according to this step. Left side and right side, elements, carbon, hydrogen and oxygen. These three types of elements are there in this equation. Carbons in the left side 3, in the right side also 3. Hydrogens in the left side 8, right side 4 to the 8. Oxygens 5 to the 10, in the right side 3 to the 6, 4 1 the 4, 6 plus 4 10. Observe here, carbon atoms are balanced, hydrogen atoms are balanced, oxygen atoms also balanced. In this way the chemical equation is balancing according to the above 4 steps. This is the final and balanced equation.